Hello, the Darkness344 here. It's been a very long time since I've recorded one of these, and this may be in two parts just because of complications and it being late at night, so I may not be able to finish the whole thing in this one part, so this may be in two separate parts. So this is we're going to be doing the display drive in this video. It's been a very long time, and we should be finishing this computer up very soon. There are a few more things that I want to do, that's why I was going to split it into a few parts. Like in this episode we're going to finish the programming the display drive. I know one or two of you might have already done that, but we still need to do that. We're going to put in the registers, and next episode we might even clear this up a bit because this is kind of unnecessarily big. And then once it's all finished, I'll give it a test out with like some program off camera, and if it all works, then on camera I'll actually program it, and we'll see the Fibonacci sequence on this computer, and I'll go through how to program it in detail, because there's no point making a computer without learning how to program it, is there? And maybe we'll add a few more stuff on the I/O, like maybe even clear ALU registers, because at the moment you do not have the option to do so, and it could be useful. And yes, we still need to work on some timings, but let's get started. So what we're going to need to do is display numbers on this display panel, and it's a 7-segment display, and the way we've wired it up means you can control each segment individually. A segment is like these 3 redstone lamps or these 3 redstone lamps, and we can control each of them individually. The only ones we can't control are the ones on the 0 column. We can only control these ones, and that is because we're not going to have any other number than 1 on this or 0. Where with 0 on this column, we're just going to have it blank, because I think that looks better. You can program it in, but it means your display might be a bit bigger. So, for the first number we're going to want is 0, 0. So that's very simple. We just leave it blank. Very simple, isn't it? 0, 1, however, we're going to need to program, not destroy it, we're going to need to program 1 on this. So that means this one and this one have to light up. The way we do that is we're going to have to turn them on. So if we go back here and we look where they're located, so this one and this one, they go down along these redstone lines. So this is line 0 and this is line 1. So on line 1 we're going to put the redstone torches down for number 1. And as you can see, mine is on line 1 already, but that's because in the last episode I accidentally left a lever over here just to try it out. So if I turn it off, it should go back to line 0, as you can see. So yours, if all of these are off, it should be on 0, even if you've just put those torches in. So what we're going to do is, just to test it out, we're going to break this piece of redstone, make sure all of the others are there, and it should display the number 1. If it doesn't, go back and check what you did wrong and try and redo it. So maybe it's not these torches don't go here, maybe you've done this wiring a bit different to me, maybe they go somewhere else. So now we need to do the number 2. So that's quite easy. It's this one, this one, this one, this one, and this one. So we're going to do these 2 first, which is this one and this one. So we're just going to go on line 2, this one and this one. Now we're going to need the middle, this one and this one. So bottom, middle. So this is middle and this is bottom, as you can see. And now we just need the bottom left. I think I've got my left right. It's this one. Great. Now we have the number 2, and we're going to have to repeat this for all of them. I'm just going to do it on camera so you can see which ones I put it on. So number 3 is this one, this one, this one, this one, and this one. So it is basically not this one and not this one. So we're going to put torches on every single one except these 2. And that one, because no one's column. I mean, no, we don't. It's not 13, it's only 10. As we can see, we've got that number. That's because I accidentally put torch here. If we break that, we should get the number 3. So now the number 4 is this one and this one. So 1 here, 1 here. It may take me some time to get this one and this one. It may take me some time, as I was saying, to get back into recording, and I think I'm only gonna put one out once a month because I'm kind of a bit burnt out. So who knows? I will try and keep recording though, so do not worry, because we are nearly at 100 subscribers. That is pretty cool. So we got the number 4. Now we need the number 5. I still haven't planned anything for my 100 sub special. I was originally gonna show off my dual core computer, but I still need to program it, and it has 1 or 2 bugs that I might want to fix, and it still needs testing out and stuff, which will be annoying. So the number 5 is this one, this one, this one, this one, and this one. So these two we're going to have to program in. Okay, that was wrong. It's up this one, isn't it? So that was the bottom one. Now we need to do this one and this one. There we have the number 5. Marvellous. The number 6 is all of them apart from this one. If you've already done this display drive, feel free to skip ahead, because this is probably very boring. I accidentally put the number 1, so now it's 16. Actually, I better test out. As we can see, number 6. Number 7 should be... 7 goes this way, doesn't it? So these two and the top one, which is that one. Top one is here. So what have I been doing in my absence? I've pretty much been doing schoolwork and more schoolwork. The number 8 is all of them, except the 1, because it's not 18. Schoolwork, more schoolwork, and more. I've also been playing on a server that I have, like a private server that I have. Number 9 is all of them except this one. And I may do videos on that. At the moment, this channel is pretty much just dedicated to redstone computing. However, the server that I've been playing on is pretty much like Psycraft or Exploit, but definitely not as advanced. We have similar goals in mind, but nowhere near on that level, because none of us are going to be willing to put in the efforts required. So now that we've done the number 9, we need to do the number 10. So that's this one and 0. So since we've only programmed blank or 1 on this one, all we have to do for 10 to represent 10 is just put a torch there. And as we could see, 10, but of course we want a 0 here as well. So that's all of them except the middle one. So if we put that in real quick, I think I just put the middle one in, didn't I? Yes, not good at all. Whoops. 10, now we need the number 11. Here's where things get the tiniest bit easier. For the rest of these we can just put torches in here. And for number 11, all we have to do is go back to number 1, which is here, and copy it. So it's these two, isn't it? So we're going to go over here and put in the 2 torches for 11. Simple. Now 12 is this one, these 3, and that one. So we'll just have to remember that, which I hopefully can do. I think that's pretty much it. So let's try that out. 12, very simple. 13 is this one and these 4. So I've forgotten what it was, but I think it's 1, 2, 3, 4. I have the worst short-term memory in the world. 13. Now we need to do 14. So 0, 1, 2, 3, 4. So it's this one. Yeah, okay. So it's pretty much 13, but this one is over here instead. Place that back. Break that one. 14 with a Y, so we got to break that one. Did I place that by accident? 0, 1, 2, 3, 4. Why is there that on 4? I went wrong on number 4. I have to get rid of that one. Was it that one? No, it wasn't that one. Oh no. I do not know what I did. Oh, that's because I have this one on as well. There we go. $14. So it was these. I must have put an extra one on this one then. Aha, that's where I went wrong. It's only these ones. Why is it off? I did not break it properly. And since this is a 4-bit calculator, it can only go up to 15 numbers. So I know it's very small, but this is just a basic calculator just to get, well, computer even, to get you started. All it does is compute, either add or subtract 2 numbers together. You can change the ALU to do other stuff if you really want. This is just to get you started in the thing. Like, by no means, I mean, I would say you could use some of the designs here, but I mean, some of them are just kind of rubbish for what you would be wanting. Like this RAM design over here is very inefficient if you're making a lot of RAM on your computer. I have much more efficient designs. This ALU is absolutely dreadful for anything other than learning. This program counter is very good, however, so I'd use a similar design like that. Just earlier today, I have been working on a new program counter design over here, which also supports conditional branching. It is a bit, I'd say it's smaller because you get double the lines. As you can see, you have lines on the top and lines on the bottom. And it's very easy to do conditional branching because you can have your program counter here and then your conditional program counter here. So it's jump to this block if so and so. But it's very simple to do. So, getting sidetracked. It has been a very long time since I've recorded, so I may be getting sidetracked a bit more. So now we need to do number 15. Burger King. So 0, 1, 2, 3, 4 and 5. So it's these 3 and these 2. So 1, 2, 3, and I think it was these 2. I may be wrong, but hopefully I'm correct. As you can see, number 15. So I'm just going to go through these to make sure you have them all. So 0 is blank, 1 is these 2, 3 is this. Should I just fly over like this? And as long as you've wired your display the same as I have, you should be getting the exact same numbers. If you haven't, you might have done a torch in the wrong place. So make sure you've got them all right. Now what we can do is come over here, and I think this is our ones column. It means we can actually put numbers in. So I think that's the number 5. As we can see, number 5. Very useful. Now, the display is great and all, and it will display whatever's on the main data line or the main data bus, which is quite useful because, you know, it's just useful in general. However, what happens if we want to make it stay on until we say, oh, update to a different thing? We're going to need some registers, and these are basically almost mini memory cells that store data till you update it or clear it, and that is what we're going to do over here. So basically we can build them right over here. So we're going to block up, and we're going to have the inside torches here. So if we just go like this, and we can remove these repeaters, they're not needed, and we'll remove these blocks in a minute. So now that we've got this, right, make sure they're on this side and not this side, like this. We can break these and put some torches down. I broke that one by accident. And we can break these blocks as well over here. Then what we're going to want to do is come around the back of these, and that's why that wasn't meant to be broken, and place like that. And we're just going to have redstone like this and break these ones. So we have something like this and one more here. Now we'll just have to clear this area out. It'll make it a lot easier. Now that we have this, we're going to place a block on each of these torches and bring it back 3 more. So we have 4 long, and we're going to just do that on every single one, and we can join these together at the end because they are all linked registers. They all are for this display drive. So if I just put some redstone down here, redstone repeaters here on 1 tick, and some redstone along here. So now that we've got this, the only thing we need to do now is place some blocks down like this. And on this side, the side where the redstone dust is, we're going to place torches down like this. And you could place it the other way if you don't want it to do that weird thing. Now to make sure that they're all the same, we can just go like that, flick a lever, and they should all be 0. Now the way we're going to want to latch these are the flip-flops, are we're going to have some redstone torches here, and then underneath these we're going to have some blocks leading in to our cells like this. There we go. So now that we've done this, basically we're going to actually want to put the input in now, and the way we're going to do that is we're going to need to turn these torches off. So we place a block here and either a lever or a torch. We'll just place a torch for now to turn these on, which means these torches turn off. So you can see the signal length for here. So what we're going to want to do is just place a torch on every single one of these on the main data line. So that is 1, 2, 4, and 8, and we just want to break it so it turns on. And as you can see, it's 1 too short. Perfect. That's a bit annoying, but what we can do is go over here, just place some blocks like this, and that should extend it. Break these ones underneath to make it look nicer, you know, it's all about looks. And as you can see, it works. It basically turns this one off. Great. Now we're going to have to break all of this. The registers are done. So let's break this and give it a try. So as you can see, the data at the moment is saved as 0, and if we update it, since there's nothing on the data line, it will be 0. But say we put the number 1 on the data line and we update the registers, it will save the number 1. And even if this is off, as you can see, it will still save the number 1, even if I go like this. Or maybe that's not meant to happen. But it basically saves the number 1. And you can do that with different numbers. So say I say the number 5. It should save the number 5, even if I change these. As you can see, I'm putting the number 2 in, but it's going to stay the number 5 till I update it, and then it will go to number 2. So this is going to be attached to our update display part. So we're basically gonna bring this, yeah, I guess this should do. And we can just bring it along like this, and it's gonna have to end up here, so I guess we can just bring it down like this. You can wire this a bit differently as long as it reaches the same place. I mean, in all honesty, you can have your button somewhere else. This is really just a simple computer that is meant for modifying this. When I built this computer for the first time and decided to do, I can't even speak, and decided to do tutorials on it, I just made it in with the intention of it being as simple as possible and easily modifiable, so you can learn how all the simple components work and see if you can add more complex components. Because if you really wanted to, you could use the same layout to make a much more powerful computer. Like over here, I have an 8-bit computer using the exact same architecture, or the way of the data flows, and it's more powerful. It got a better ALU, though the ALU is kind of dodgy, and it even has conditional branching, which is kind of broken on this one, but that's because I missed out something in the programming. But I know how to fix it, and I even have enough space to fix it, as you can see. But I'm not going to fix it because, yeah, oh well, I cannot be bothered to. So now that we've done the registers, they are a lot smaller than I imagined. That's quite sad. We have all this spare space. What we could even do is include a binary display. So, I mean, where should we include it? We could include it up top, you know, or to the side. Should we have it right over here? Because I mean, you could just look this way and see the display. And this display will, or should we have it here? No, we'll have it right here. So I don't really know how to put this. I guess we can just grab some concrete like this and go down a bit like this. And this can be our binary display, and we'll display whatever is on the data bus at the current moment. So I think we're going to have to go like this. Then we're just going to wrap this around like this. And it looks ugly. You can move it somewhere else if you really don't like it. It has to be 4. But I'm just going to put it here because this is nice and simple and very easy to do. That looks extremely ugly. I'm going to raise it 1 up. It has been a very long time since I've recorded. You can definitely tell. There we go. It looks kind of out of place, but it'll have to do. And this, we're just gonna bring these along like this. And so if we want this as 1, 1 is over here. So what we're gonna do is we're gonna bring 1 up like this, 2 up, 3 up, and 4 up. That should be not in line for some reason. Aha. And this one we can just bring across like this. This one we're going to have to go like this. Actually, I'm going to bring all of these across to here, because it has to look nice. So basically what we're doing is bringing the 1 from here to this redstone lamp over here. And as you can see, it's as simple as that. And we're going to do the rest with 2, 4, and 8. And we're going to need some repeaters. You can stick 1 here. I can't even see if it's on or not. It's clearly off. And we'll just put one there. Actually, that looks bad. We'll put one here. Okay, there we go. So now we have our 4 lamps that are on. And I wonder why they're on. Aha, that's because we have these. This won't slow down performance, but we'll put repeaters here to block this signal. It won't slow down performance because the display is not part of the computer, it's a separate module, so it doesn't matter how fast it is as long as it roughly more or less displays the number on the same cycle, more or less. It doesn't really matter how fast it is as long as it can kind of keep up. So repeaters, just a tick of delay will not matter too much. And that is why these are all has a lot of repeaters in. That's why I built this module as compact as this, because it's very simple and it's very compact. However, it is slow for the size. Well, for a thingy. So, as you can see, we have the number 2, which is what we last saved. So now what we're going to want to do is we're going to want the update display button over here. And we're also going to have to link this up into the update display program line as well, which I think we still have, don't we? Display, perfect. We even had it going over, didn't we? So, what we're going to do is we're just going to place lever, flick it. That won't work. And we're going to have to make sure this can lead all the way over. And since this is just a stone button, it doesn't really matter about timings too much. I'm just going to put that there so they all go on the same tick. We don't really have to put a pulse lengthener or shortener in here because all we have to do is hit it once. And say I had a different number on the display, different number like 5 on the main data line. So you can see 5 is on the main data line right now. I can update display manually and it should come up as 5, as we can see. So let's break these levers because we do not want them. And it would still be 5 even though there's 0 until you update the display. If you want it to show whatever's on the main data line, skip the register part, don't have them at all. However, this register part means it will always show the saved number, which is preferably what you want. Because if it's doing other things but wants to display a different number, you're going to need registers. So now that we've done all the registers and widened the display, I think all that we need to do now, in this part anyway, is... I'm trying to think. Oh yeah, wire in the other updater thing. Okay. So over here, we've already had it going down, where we have this cable right over here, so we can bring that down onto the same level. It's pretty much the same level, isn't it? And bring this across like this. There we go. Break all of this, we do not need that. So what we're going to do is place a redstone torch over here, break this so it turns on, and now we can see the signal length, and make sure it is 15. And a repeater there. And there are a lot of ways to lengthen signal length, like so we're just gonna take the signal length, make sure. Oh yeah, what was I saying again? I was saying about ways to make this go longer. So the easiest way, most people would have thought, just put a block here and it makes it go one longer. However, the other ways is put this repeater over here, and as you can see it just doesn't reach by 1. Put a block here and also put a block here, and that will make the signal longer by 2 blocks. However, I don't do that because sometimes when you, as we can see, there we go, sometimes when you leave the game and join it again, it sometimes breaks because of chunk chunk's just not really working that well. Actually, I'm just going to break all these torches. So there we go, we have a display update on the actual program and a display update on your user interface. So you can either update it manually or in the program. As we will see later with the Fibonacci sequence program, it can update, the computer can update the display if it wants to. This display is not controlled by the registers, it will only display whatever is on the data line. So if the number 5 is on the data line, that's not the number 5. That's, I don't even know what number that is. It doesn't even reach. But you get the picture. If I have a number on this line, it should display that number. Now, I might as well label these as well, just so we do not get confused. So I think this is 1. Oops. And this, I placed that wrong. Please escape the sign. There we go. And if I put in the number 1, which is this, just use a lever, it should light up 1. There we go. Very simple. Now, I'm going to tie the cables up here, and the way we're going to do that is, because this is kind of stupid, the reason why I did this was because I made an error where this was connected to it. If this is still connected to it, that means your computer is going to break. Destroy these, make sure the RAM, make sure you don't destroy that torch, make sure the RAM is not connected to this or it will break it. However, we can take this and bring it along like over there, because it's very convenient. So we're just going to break these, and we're also going to move this all the way up to here. Lag. So we're going to want to make sure it's in line and not touching this one, and we're just going to want to bring it along here. This, I think, will only speed up the performance by like 1 or 2 ticks, but it's probably worth doing just because 1 or 2 ticks with a computer this size, it's only a 4-bit computer, so even the smallest increase in performance matters. Like if I really wanted to have this go super fast, I do not know why this lag, I would set it up as compact as possible. Hopefully my recording is not laggy, because last time I was recording, some reason it was laggy and stuttery, and that is really annoying. And there we go, that should do it. And we'll just bring these along like this, and they'll eventually connect up to there, but we need to destroy all of this useless rubbish. Okay, it's really lagging. I really hope my recording's not dying. This should be fine. And it means the computer will look a lot nicer, in my opinion anyway. So we're just going to want to come out like this, as you can see, and now we can just go up on each of them. And the reason why we're doing this is so it connects with that. Make sure it's in line on the same height. And that should eliminate at least 2 ticks. At the very least 2 ticks from those, the redstone torches. And hopefully this should be the slightest bit faster, meaning if you want to get into overclocking this computer, I know it really sounds stupid, I overclocked my Minecraft computer, oh yeah, I made it go a measly 0.5 hertz, oh yes, what an achievement. I mean, you can technically, because I've set it at a certain clock speed, but if you manage to make your computer faster than mine by like putting repeaters in certain places, like with that repeater technique that I showed, if you did it over here then it'd be faster. So now we might have to redo all of these repeaters. That will be very fun, just to make it the slightest bit faster. I mean, we could, or we could be lazy and leave it. I mean, it's only a tick, you know, only 1 or 2 ticks. We should do it. So we're just bringing this first lane. Yeah, I mean, I think it might only save like 1 repeater. There's really not much point doing it. This part we can do, but I mean, there's not really much point doing anymore. What I'm gonna do is, I want it looking beautiful. Has to look beautiful, you know. That should definitely make it up. Yeah, that's gonna have to go like that. There we go. That should pretty much do it. And that should come out on our main data line, which has not yet. Or has it? Oh no, it has. I just didn't see it behind the science. So now it looks a bit better. I don't know, you might be able to tidy up a bit more, but it's going to be the slightest bit faster. And remember, remove any levers or torches you have lying around, because those are very annoying. And make sure you don't break anything, because the slightest block, like say that was missing, it's going to break the whole thing. And you're going to be very unhappy that you spent all this time making a whole massive computer just to find out just one small block is missing in some peculiar place, and the whole thing breaks, because that's what happens. Like if one block was missing in this, it could break the whole thing potentially. It's quite temperamental with that sort. So make sure you follow the tutorial perfectly. I mean, if you know a lot about this, you'll probably be able to make it in a different way and stuff, but yeah. So now that we've done the display drive and finished it up a bit, why don't we write a small program to display the number 5 in the display. Actually, we'll make it display the number 12 for a change, you know. It's always been the number 5. So I'm just going to break these. So on our line 0, what we're going to want to do is all we're going to want to do is display the number 12. So that's 8 plus 4, that's 12. And we're going to want to display it. Then on, I mean, we could just try out the program. Let's try it out. If I just clock it once, actually it's off, isn't it? It won't do anything. If I turn it on and clock it once, 12, perfect. And if I do not why is this not on? The repeater is not long enough. Aha. Perfect. What we could, if I just turn it off and re-clock it, let's write a program to display the number 12, load something into the RAM to make sure it doesn't display that number, and then display the number 5. So number 12 on this line, and then go to line 1, which is this line. On line 1, we want it to load into, say, ALU A. We're going to load the number 3. So it should load the number 3 into the ALU A register, but not display it on the display. It should display it on that small display, but not that one. And then on the next line, so we're going to say on line 2, we just need to break all of this. On line 2, we're going to stay on line 2 because that's when the program ends. There's all of this stuff on these lines. Make sure to destroy it all, just so it doesn't do anything. it shouldn't be touched here anyway, because it'll stay on this line, because this is line 2 and we're saying just stay on line 2, so it won't go to any other lines. It'll just halt the program. And we're going to display the number, what did I say? 5. So display the number 5. So 5 is 1 and 4. And that should pretty much be the entire program. So if we turn the computer on, it should be line 0, so 12, and we're going to turn the clock on. So now it should have loaded the number 5 into the ALU, and now once the clock's finished it should display the number 5 eventually. Clock is on, right? Pretty sure that's not connected. Does that look connected to you? No. It's not connected. I've forgotten to connect it. We're going to clock it manually. So the first clock does that. The clock manual's not connected either. Okay, I found out something we're going to be doing today. Yay! I don't even know where the registers are. They're down here, aren't they? Oh, this is going to be annoying to do. Okay, so we need to connect this up, don't we? So we can go from here. What I'm going to do is just go down like this. So actually we can just clock it manually from here. So that should go on to line 2, as you can see, and it should load number 3 into ALUA, which it has, and it displays for some reason. Why has it displayed? We did not update it, did we? Or did we? The display line does not say update. That may be a problem. What we can do to fix that problem, however, is break that, place a torch there, place, break, go down like this, just put a repeater here on 4 ticks, go up like that, place the torch here, block, down like this, and actually we're going to just go up like this, so we'll place a slab around here, and this will go into a NOT gate, like that, block on top of that, and there we go. So whenever we power this, it'll just update it once, as we can see. So now we're going to restart this by turning it off, and just re-updating the display. And now when we turn it on, it should put the number 12 in. It's not on the right line. So yes, we definitely need to hook up the thingy, don't we? So also what we might want to hook up is whenever you turn the computer off, it defaults back to line 0, but I mean, that's up to you guys, I guess, and I'll show you how to do that. So first of all, we still need to do this. So from this, we're going to have to go down. This is going to be a very tight fit. Extremely tight, in fact. I guess we can just use some torches. And this will need to go here, won't it? So what we can do, we don't need to knot this because it's knotted down there. So we just need to get this and this to the same level. So we're just gonna keep going and staircasing down like this until they are pretty much the same level. Those are the same level now. So actually I'm gonna wanna come from here, aren't I? And now this line should end up in this torch over here. There we go. Perfect. And then of course we need to do this. And if we turn this on real quick, it should reach all the way up to there. So, yeah, make sure you've broken that lever. We do not want that there. And this should definitely reach all of them if it doesn't add a repeater in. Now, this should reach that, meaning if we power this permanently by just turning this torch, if we actually do like that, it should go off and on again because of that. So we're actually going to have to break it like this, and that should turn that torch on. And as you can see, there we go. And I probably broke, no, I just reset the RAM. So now what we're going to do is it should actually start functioning as a clock. As you can see, it is now clocking. We've got the actual clock, as you can see. It's not the fastest clock in the world, but that can change if you want. And it works, that's the great thing. What we're going to have to do though is, of course, try out the program. So we're just going to turn that off. Make sure everything's stopped. We're going to reset that ALU just for, we're going to reset the registers just because we can. If I go like that, that should have reset them. It has. Just so we can see if it actually does put the number 3 in the registers. And we're just going to put it on max clock speed, so it works. Update the display. 3, 2, 1, and go. Oops, actually, we have not turned the computer on. That will not work. So if we turn the computer on, it should put the number 12 in, and now we can start the clock. It should save the number 3, so as you can see, 3, and it should have saved it to the ALU. And now the number 5 onto the display. As you can see, it has, and the number 3 is in the ALU, and the number 5 is on display, and it has stopped on line 2, and it will remain stopped with no flickering, hopefully. I'm just waiting to see if it flickers. No, it does not. Perfect. Okay, that is the display completely finished. Both the displays are completely finished now. And remember to, whenever you turn the computer off, clock it. Always clock it once, because the clock's still on, isn't it? No, it isn't. That's just me clicking the clock button. Always clock it once, because sometimes it will need clocking. What you can always do is hook this up to this over here, but since they're not really close, it's going to be a bit hard to do. So whenever you have a NOT gate here, and it leads with a small delay into here, so whenever you turn the computer off, the NOT gate turns on, meaning a line redstone goes into this, pulsing it once and clocking it once just to reset it back to line 0, because you always want to start off from line 0, don't you? And if you don't want to stop on line 0 and you just want the computer just to halt, you can just turn it off and the clock can still be running, and then when you want it to resume, you can turn it back on. Very simple. So now that we've done this, I hope you enjoyed this episode, and we did not have to split into 2 parts, luckily. So yeah, well, yeah, I guess please like and subscribe, and yeah, hope you can get this computer finished if you guys are making it. If you're just looking at it, then I guess I hope you actually learn stuff from it. And I spot a piece of redstone missing. Better fix that. Yeah, please like and I can't even speak now. Please like and subscribe, and I am out. See you later.